The third episode will get you familiar with trend analysis, curve-based inspection, tables and diagrams, and finally, how to evaluate blades. Trend enables the handling of multiple components within one project, which was created in GOM Inspect Professional. The inspection then takes place not only on one part, but on several parts at once. All software concepts stay the same, such as the surface comparison, but in Trend, multiple parts are handled over stages, which you can select. The results for each stage will be displayed immediately. You may then deduce a tendency about how the part changes within a series. The legend is now extended and allows you to view not only deviations, but also range, sigma, or even statistical information like CPK. The Stage Explorer enables you to select a specific component as reference, not only to compare to CAD, but to Part 2, for instance. It is also possible to extend your inspection at any point, such as the inspection of a circle regarding its diameter. Any inspection will be then recalculated for all stages automatically. You can now change the stages and get the results displayed immediately. In addition, you may change the label template over the Edit button of iInspect in order to display tendencies. Curves is a concept that completes the idea of full field inspection data. Rather than having point-wise information, such as the trim and spring on the sheet metal, GOM introduced the idea of having the data also in between. The applications reach from radii analysis over trim and spring up to flush and gap analysis for inspection and contrast line and tapes for reverse engineering. Let me demonstrate this with the following example. We would like to know the radii deviation along this curvature. Thus, we construct a surface curve, which we can find here. Make sure you have the marker snap selected to max curvature. Then we have to set a start point with Ctrl and the left mouse button and an end point with Ctrl, Shift and the left mouse button in order to trace along the surface tendency. We can reproduce the same on the actual data via measuring principle fitting curve. To determine also the radii, choose the measuring principle radius. As everything is being calculated, we choose the check deviation radius. Discrete values for the radii deviation are available over the button Point-Wise Inspection in the main toolbar. So perhaps we would like to use equidistant inspection points for the radii. It is easy to display inspection results also as tables. You can find the tab Table in the inspection workspace. Decide in what format you would like to display the results. You may view only visible elements or all elements. Or sort the data by perhaps the highest deviations. Export the tables as a CSV file for working with spreadsheets, or document it with a report. Or perhaps just with a table. For curves are diagrams available which show you the results as graphs. You may change the legend in order to see the curve deviations within the tolerance band. In GOM Inspect V75 SR1, we introduce some highly flexible functionalities for section-based analysis of blades and aerofoils. Typical blade or airfoil properties that you might want to inspect can be seen on this drawing. As mentioned, a section is always the base element for the inspection, and thus we have to create it. We construct the section on the nominal data and create also the actual element via measuring principle actual section. The construction of some aerofoil properties is standard, and these are provided in the interface. For instance, the mean line, which we can find now on the iInspect. The mean line is usually the foundation of further inspections. Another standard inspection approach would be the diameter determination of the leading and trailing edge. We can construct and immediately inspect it as well. However, for some aerofoil properties, there are many possible approaches. A good example is the inlet-exit angle property, for which there are many different construction schemes in use or possible. These non-standard aerofoil properties are not directly provided, but can be created by the user using a combination of blade and standard GOM Inspect functionality. Let me show you how it works. We construct edge points first, which are the piercing points between mean line and section. Now, we use a two-direction angle to measure the angle between the edge points and the turbine axis and reference the construction on the scanned data. Other approaches for an inlet and exit angle can be accomplished too, like in this example. Use the standard blade functionalities in combination with all other powerful inspection functions within GOM Inspect to fulfill your own company-specific or blade type-specific approaches. Please visit and register at support.gom.com. For further tutorials, to access an extensive knowledge base with hints and tips, to interact with other GOM Inspect users in the GOM forum, and to download sample data and software updates. Download your free copy of GOM Inspect at gom.com, where you can also obtain more information about upgrading to GOM Inspect Professional, the parametric inspection solution with innovative teaching by doing technology, and to learn more about GOM's optical measuring systems for 3D coordinate measurement and deformation analysis.